Hey everyone, and welcome to this last lecture on the series of complex numbers. I'll be just going through the overview of what we have done so far in complex numbers, and I'll be introducing to you the last concept that we'll be studying in complex numbers, and that is of polar coordinates. So basically what we have covered so far is that first of all we started with the definition of the complex numbers, which is that I is equal to root of -1. Whenever we have a negative radical, we use I to solve that equation, solve that function. I basically means an imaginary function, and a complex number will have this form, that is x plus iy, x being the real part and iy being the imaginary part of the number. So this is explained over here that the real part would be x and the imaginary part would be y if z is the complex number. If there is no real part, if x is equal to 0, if you have something like 2i, then it will be known as a purely imaginary number. It will still be a complex number, but we will call it a purely imaginary number. We won't be saying that because it does not have any real part, so that's it. The only thing that complex number will have will be an imaginary number. Then we went through and talked about the addition, subtraction. That was pretty straightforward, and the multiplication. One thing that I wanted to go about with this the arithmetic is one thing I wanted to revise was this the concept of complex conjugates. So the complex conjugate concept is pretty straightforward. This is used when we have to divide two complex numbers. If we have a complex number x, z is equal to x plus iy, we find its conjugate, and the way to find the conjugate is we represent it with the star, or you can represent it with anything you want. The way to find a conjugate is that you change the sign, that you change the of the complex number. That is it, and that's the complex conjugate. Instead of x plus iy, if you want to find the complex conjugate of this, you have x minus iy. Two complex numbers, this is a new thing that we're going to study right now. This is a new thing that I'll be introducing right now. I won't be going into the details of this because this is pretty straightforward. Two complex numbers are equal if and only if the real parts are equal and their imaginary parts are equal. So if both of the parts are equal, that is if it's 2 plus 2i, only if x is equal to 2 plus 2i and y is equal to 2 plus 2i, then we will say x and y are equal. Other than that, we can't say that two complex numbers are equal, because this is the rule for the complex number to be equal. Then we went on to study about the complex plane, which is also known as the Argand diagram. The difference between a complex plane and a normal plane is that the complex plane has two axes rather than the real and rather than the x and the y. It has the real and the complex in the imaginary axis. The x-axis that we normally know, that is the horizontal axis, we have the real part over here, and the y-axis that we normally know, we have the complex part over here. So we plot any imaginary number with respect to this, the real part being covered by the horizontal axis and the imaginary part being covered with the vertical axis, that is the imaginary axis, rather than the x and the y. And there are two things that we can calculate out of this. One is of course the argument, the other one is the modulus that we covered after this. Now, in order to study this concept of polar coordinates, we need to relate it to what we did what we did in the complex plane. So the polar coordinates are basically what we do in polar coordinates is that we over here, if we have to find x, that is we have to find this will be known as r. So this is r and this will be cos theta, because x is basically the r and the cosine of the angle that this modulus makes with the x-axis. How do I know this? This is r. So r is basically the modulus of the real and the imaginary part. What do I mean by that? What I mean by that is that if I have a complex number that, like I have in this diagram over here, that is z is equal to x plus y, I will be working with z for this example. So the modulus of this will be x squared plus y squared under root of that. Just like I explained to you that we'll do it like we do it for a circle in the Pythagoras theorem. So this will be the modulus, and in order to find the argument, that is this angle over here excuse me, we basically use this trigonometric ratio of cos and we find the argument of this. That is, if we have to find the value of x, we use z is equals to x is equals to r, this being r, cos of theta. This will give you the value of x. On the other hand, if you have to find the value of y, that is what is the coordinate of y, we can't, rather than trying to find this angle minusing this angle from 90, we can do it in a single step, because this is just like a triangle over here. So we make a vertical line over here, and then we can use the sine to find that angle. That would be r sine of theta. So if we will find the perpendicular to this theta using this hypotenuse, that is r. Once we have done this, these are known as rectangular coordinates. So these are rectangular coordinates, or you can also call them Cartesian coordinates. Once you're done with that, first of all, you need to know two things. Rectangular coordinates consists of the modulus and the, so what I'm talking about basically, sorry I said rectangular coordinates, what I mean by what I was trying to say was the polar coordinates. The polar coordinates are the r, the modulus and the theta. These are the polar coordinates, and the rectangular coordinates are the x and the y, that is the real part and the imaginary part. You can another thing that I want to show you on the slide is that z into z star, that is static over here. Why have we done this? Because if you multiply x plus iy and x minus iy, that is, if you multiply two of these, you're gonna get a conjugate. If you multiply two conjugates, that is z and z star, like we discussed over here in the first one, that we wrote z star as the conjugate of z. If you multiply both of these two, you're going to get x squared plus y squared. So just to make it easy, just to have a further understanding of this, you can write it like this. So basically what you need to know is that the rectangular coordinates are the x and the y, and the polar coordinates are the r and the theta. And once you have both the values, this is known as a polar form. You can write it down like this. So if you have to write down, you can write z is equals to r. Like if you have a complex number of z, and you need to find, first you need to find the r, which you find through this. Once you're done with that, you need to find the theta, that is the angle. We discussed about that as well. So once you're done with that as well, you can write it down like this. We'll cover this more shortly. So this will be your polar form. So we covered x and y in the previous slides, and we covered r in the previous slide of the polar coordinates. In order to find the theta, this is how we do it. So basically what the theta is the angle, the geometrical angle from the horizontal axis, from the positive x-axis to the OP. What is OP over here? This is the modulus. This is what we found through what we discussed over here, that is, this is what we used to find r. Once we are done with that, now we need to find theta, and the way to find the theta is it's pretty straightforward. We use tan, because we have the value of the perpendicular, we have the value of the base, and we use this to find this the value of theta. That would be y over x, that is the imaginary value over the real value, and that way we can find the theta. We already have x r, so this will be the value, this would be the form that you can write down in terms of if you have to write down the answer in polar form. So this is how the polar form would be. So this diagram pretty much sums it up really good. So x and y, the ones showed in blue, these are known as the rectangular coordinates, and r and theta, these are known as the polar coordinates. So another interesting question that you're going to get whenever you're solving this in engineering and math and physics is that you would need to convert these from polar to Cartesian. Cartesian are known as rectangular, and from rectangular to polar. And the way to do that is that if you have polar coordinates of r and theta, that is pretty straightforward. You can memorize this, but I would rather suggest that you should understand this, so you don't have to, you're not gonna forget it afterwards if you understand it. So x over here, that is rectangular coordinate. If you have to find that, of course, if from polar coordinates. Now polar coordinates basically mean r and theta. If you have these two, so what you can do is r cos of theta. Why? Because r is this absolute over here, and theta we have, and cos would be basically the base and the hypotenuse, the ratio of the base to the hypotenuse. So that way we can get x, that is, we need x, so we multiply the cos theta with the hypotenuse r. And for y it's pretty straightforward as well, which would be sine, that would be the ratio of the perpendicular to the hypotenuse. So we have the hypotenuse, we have the theta, and we use sine for that, we get the rectangular coordinates of this. On the other hand, if you have Cartesian coordinates and you need to convert it to polar form, so like I said, there are two things to the Cartesian coordinates, x and y, and there are two things to the polar form, that is r and theta. In order to find polar coordinates from Cartesian, you need to find r, and the way to do that is pretty simple. All you do is take the sum of x squared and y squared and under root it, then you're gonna get r. And as for the theta, well, there are many ways to do this, because now you have three coordinates. You have an x, you have a y, and you have an r. So it makes a perfect triangle, perfect 90-degree triangle. You can use any of the three ratios over here, whichever you're most comfortable with, to find theta, because it's just pretty straightforward. I mean, if you look over here, you can use cos and you can use x and r, base and hypotenuse. You can use sine, you can use perpendicular and hypotenuse, you can use tan, you can have the perpendicular and the base. You can use any trigonometric ratio that you want to find the answer to this question. So all you basically, or you can, if you can't draw this, if you just want an answer right away, so just find the r through this and just find the theta through this, just y over x. But that would of course be rote learning and that won't take you a long way, but it's much better to make the concept. Now let's do an example. Find the rectangular coordinates of the point with polar coordinates under root of 2 and 5 pi by 4. Now before I do it and show you what the answer would be, I would like you to try it on a piece of paper. So we have polar coordinates, we have two things over here. We have under root of 2 and we have theta in the form of pi. So what do we have? What do we need? We need to find rectangular coordinates. Rectangular coordinates are x and y. So it shows over here this is x and it shows over here this is y. So in order to find x and in order to find y, we'll use these two trigonometric ratios over here, cos r cos theta and r sin theta, and then we can find the rectangular coordinates. So why don't you go ahead and try this and try to find the answer for yourself, and let's see the answer now. So this is basically the answer. X is equals to r, and r is under root of 2 cos of theta, and theta is 5 pi under root of 4. So they basically substituted 5 cos under root 5 pi by 4 by this ratio over here, -1 by under root 2, and we get the answer -1. And y again is, what is y? Y is basically r sine of theta. Now we have r under root of 2, we have theta 5 pi by 4. So through this we can find the answer to this question. Now let's do the second example, which is the other way around. Find the polar coordinates of the point with the rectangular coordinates under root of 3 and 1. The first thing is that what do we have? We have the rectangular coordinates. What do we need to find? Rectangular coordinates. So that would be an x and a y. So we have an x that is under root of 3 and y that is 1. On the other hand, what we have in terms of the polar coordinates is we have r and theta. This is what is given in the this is what we need to find. So we need to find r and theta. We're given x and y. How do we do that? So in order to do that, we use this to find the r, and we use any of these three to find the theta. So why don't you guys go ahead and give it a try before I can show you what the answer is. So this is how we solved it. R is equal to under root of 3 by 1, and we get the answer is, that is 2. And in order to find theta, well, I have shown you two ways to find the theta over here, cos theta and sin theta. So cos theta, as it is said over here, is x by r. X we know is under root 3, r we just found out is 2, so cos theta would be under root 3 by 2, and sin theta we showed over here is basically y by r. So y over here is 1 and r over here is 2. So you get this answer. You can use a calculator to solve this, and then you can get the polar coordinates of r and theta as 2 and pi by 6. So it's pretty straightforward. Just remember for the polar coordinates that just remember this thing. Basically all you have to do is everything is available in this slide. There are two types of coordinates, that is the x and y, that they're known as Cartesian or rectangular, and then there are the polar coordinates, which are r and theta. And the way to find that is given on this slide. I would like you to basically remember this four values of a triangle over here: x, the real part of a complex number; y, the imaginary part of the complex number; r is the modulus of x and y; and theta is the angle which is the positive angle that x, that is the real axis, makes with the modulus, that is r, the modulus which has a value of r. So this is pretty straightforward. If you remember this triangle over here, you don't have to remember this. Just keep in mind x and y rectangular and r and theta as the polar coordinates. So that's pretty much it with complex numbers. We'll be starting with coordinate geometry after this. Hopefully you'll join me for that as well. Thank you very much.